Okay, this lecture is actually going to be from the second half of this manual. This is really one manual, but divided into two bindings for convenience. So you've got fundamental programming. That's the majority of the lab projects. Then you've got programming examples. So this particular lecture is going to talk about a lab project in here, and it's called Just for Fun. The reason I call them Just for Fun is because they're kind of just frivolous asides that I thought might enrich the whole process. So this one is from the second volume. If you want to call it volume 2, that's fine, but from Programming Examples. We pulled all that out of the first volume to tidy it up into just the fundamentals. So this is not the fundamentals. This is the first of a couple just for fun. Let's do it. Okay, here we are. We're about to discuss our very first just for fun. It's on approximately page 90 in the manual, roughly. And we start out by asking you to set up your graphical user interface. This is our lab as we left it, and it was called L31 program tags. And so we save it as such, but just to be on the safe side, I would probably save it as just for fun. That way there's no chance of messing up this current lab that you're going to start off and use again after we get done with it just for fun. So I'll just type in J for fun 01. You could have used something else, but I always encourage you to save everything with unique file names, that way, and make them something that you recognize so you can go back to it, recoup something you may have lost. It wasn't necessary to upload the tags and save them, but why not? We're going to do this online in the run mode. We are online in the remote program mode, so we'll change it to the run mode. And then I had you single left click here to select that rung, just as you would click to the left of a line of text in a word processor document. From your keyboard, do a Control C and a Control V. So Control C is copy, Control V is paste. There's a second rung. Double click to select and edit rung 0. This one, double click. See, now you're online. So I is for insert, R is for run, not replace. We are inserting another rung, and we have one in the edit mode, but this is the one that's running right here, the one in the middle. Then double click and select this instruction. So don't double click on the tag, double click on the instruction. I could just have you type in or edit the text, but instead I had you drop down the list and select the true if off instruction. Hit enter. And then I had you mouse over my second bit and hold down the left key and drag it over to this instruction. Then I had you mouse over my first bit and drag it up to here. Click on Finalize All Edits. And again, I point out that message that pops up, it pops up every single time you finalize all edits. You should read it at least a couple of times until you're comfortable with what it's saying, and then I wouldn't pay much attention to it after that. Now, also, each time you complete edits, the errors panel that's down here, see errors, will pop up whether there are errors and or warnings or not. And if you look down below here, there's our watch panel, search results, and errors. So always you have two sets of tabs here. When this panel comes up down here, you'll have tabs down here as well. Now you should be witnessing the 2 bits addressed by this logic toggling on and off. If you look here, you can see these bits are toggling on or off. Now they're not toggling on or off and off at the rate that you see on the screen, because the screen, by way of the laptop, cannot keep up with the processor. These bits are actually toggling on and off. Let's go here to main routine, main program, properties. Go to monitor. Now that we have 2 rungs, our scan time is just a little bit longer. Now we can reset the max, but every once in a while you're going to have a scan that has a little bit of background work, but typically it's around 18, 20, 21 microseconds. Every 21 microseconds you're scanning through here, so these bits are changing state roughly every 20 microseconds, but the screen is not going to keep up. You can't go by what you see on your computer screen as an accurate depiction of the rate of change in the actual controller. If we look at this logic and describe it, if we just to clarify, we can't toggle this bit because we don't know whether it's going to go on or off, but it really doesn't matter. Let's say that we start with this, both bits off. My second bit and my first bit are off. If that bit is off, then that instruction is true. It turns on my first bit. This rung is true. It turns on that bit. And now that's false. Turns off that bit. That's off. So it turns off that. So you see these 2 rungs right here kind of chasing each other. Every other scan, on the very first program scan, this is off, turns that on. This is on, so it turns that on. Since this is no longer off, then it's on. If this is on, then turn that on, turn that on, turn that on. If this is off, in other words, if this bit is on, then this is going to be false. Turn that off, turn that off, turn that off. If this is off, then turn that on. This is on, turn that on. Then this is false. Turn that off. This is now false. Turn that off. So you see how it cycles. Now, we don't write code this way. This is scan-dependent logic. It's intermittent. But I want you to see this because this definitely introduces you to something called scan-dependent logic. If we bring up the watch table, you may see the bits go on and off down here. You might, oh, there's off, there's back on. You see it's at an erratic rate. Let's explain this one more time. And to do that, I'm going to pause. I'll go to the program mode. And this is exactly what I wanted. Both bits off. See, both bits off. True if off. So this is true because my second bit is off. This is false because my first bit is off. Both bits, my second bit and my first bit, are off. So if we look at this logic, this is a true if off instruction. Therefore, if my second bit is off, which you see down here it's 0, then this instruction is true. Then it turns on my first bit. Now we're in the program mode, so I am going to simulate this by toggling this bit on. Okay? Now that I toggle this bit on, this bit is now on. Because this is a true if on instruction, true if off, true if on. Remember, this is one program scan. We haven't finished one scan yet. This was true, so it turned on my first bit. Then it drops down to this wrong. Because my first bit is on, this instruction is true, and it turns on my second bit. And notice when I turn it on, this becomes false. So on the next program scan, this is false. So the false execution is to turn that off. If this is off, then this rung is false, and the false execution is to turn that off. But then you see in the next scan, this is now true. This was just for fun, scan-dependent logic.